Hello and welcome to your third video on this topic. Today we're going to be looking at an application, so a type of problem where we might use separation of variables to solve. And before we can actually get to that application, we need to I need to introduce you to a little bit of vocab. So here's a little vocab practice on this handout. This handout is posted if you'd like to print it. And what this says is if you have a differential equation in the form dy dt, so with respect to time, the derivative of a function with respect to time, if you have a constant, so some number, times that function, that y there, then y is said to change at a rate that is proportional to y. So if you are so this is your change. So you're changing at a rate that's proportional to y. When you see that word proportional, it basically means to multiply by that constant. So k has a special name. It's called the constant of proportionality. And if your k is bigger than 0, it's a growth rate. If your k is less than 0, if it's negative, it's a decay rate. This part really won't come into play for us, but k is called the constant of proportionality. So to get practice with this idea that if y changes, this is the rate of change of y, at a rate that's proportional to y, you just multiply the constant by y. I have a little practice down here with that vocab. So if the rate of change of p with respect to t, so this right here, the rate of change of p with respect to t, rate of change is the derivative. So that's the derivative of p with respect to t means the variable is t. If that's proportional to p, that just means you multiply the unknown constant by p. That's how we use this vocab. If we have a rate of change of y with respect to t, so let's start with that. The rate of change of y will be the derivative of y with respect to the variable time. If that's proportional to the product of y and t, if it's proportional, we're going to multiply by the constant of proportionality. And the product of y and t is y times t. And that's it. So this is just a little practice with vocab. And believe it or not, there actually could be something similar to this in the multiple choice part of the AP exam. And then my last practice here is the rate of change of y with respect to x. So rate of change is the derivative. Rate of change of y with respect to x means we're using x as the variable. And if that's proportional to the reciprocal of x, the fact that it's proportional means we're going to multiply by a constant of proportionality. We call it k usually. You could use different letters technically. And it's proportional to not x, but the reciprocal of x. So you're going to multiply that by 1 over x. Okay, so that's a little practice with the vocab and the setup. Here's how we're going to apply this in the work that we do. What we're going to have is if we have y changing at a rate that is proportional to the amount present, so that is y itself, then the differential equation is in the exact form this. So we're not going to be using a reciprocal here. We're not going to be using a product here. This is just going to be a little more straightforward. The rate of change of y with respect to time is proportional to y. It's proportional to the amount of y. Then if you have a differential equation in this exact form, if you integrate using separation of variables and you solve for y, you get this format. And what we're going to do next is I'm going to show you that we actually get that format. So and this basically is a formula. So what you're going to be able to do is when you get up to the AP exam, either memorize the formula or do the process of separation of variables to arrive at the formula. That'll be your call. So here's how we get to that formula. I'm going to start with dy dt equals k times y. We're going to use separation of variables that we've been learning to solve for y as a function of t. So my first step here is to move dt to the other side. And then I want all the things with y over here, so I'm going to divide by y. And then what we're going to do is integrate both sides because the k here is a constant, so that's just a number, so we don't need to move that to the other side. We can leave it where it is. So what we're going to do is we're going to integrate both sides. Excuse me, you can come in. And when we integrate this side with respect to y, we can't reverse the power rule here because we have 1 over y. That's that special case where we find the antiderivative of 1 over y, which is the natural log of absolute value y. I'm going to skip the plus c because I'm going to put it on the other side. And then the antiderivative of k with respect to t is going to be k times t because k is a constant. So if you're going to find the antiderivative, that's going to be linear. And then we're going to put the plus c over here. All right, now the next step, this is actually the general solution. But we need to solve for y here because we're supposed to end up with this, believe it or not. I know this looks nothing like this, but it will by the time we're done with all of our algebra. So here's the next step. And you're going to want to make note of what time it is in the video because you're going to need to do this on the take home for number 3. So if we want to solve for y, and y is trapped inside this log, what we want to do is, one way to handle it anyway, is to exponentiate both sides. What that means is since natural log is log base e, I'm going to select a base of e, and I'm going to raise e to whatever this left-hand side is. And then I have to do the same thing to the right-hand side. So I'm going to select a base of e. The reason I selected base e is because natural log is base e. And then I'm going to make the right-hand side an exponent. So this is called exponentiating both sides. Exponentiating. Exponent. Oh, I have an extra on. Exponentiating both sides. It's one technique for solving. So because that y is trapped inside the log, we're going to pick a base e to match this base. And we're going to make left-hand side and right-hand side exponents for that e. Now, this is a composition of inverse functions. So what happens is e to a power, if it's raised to the log base e power, is going to unravel and leave you with absolute value y. No longer an exponent, just like regular absolute value y. And then this side is e to the kt plus c. Okay, next step. Next step is to use a little property of exponents, and I wouldn't expect you to think of this on your own until you've seen it, until you've seen us do it here. All right, so what we can do is we can actually separate this because we're reversing the rule that says if you have a product of two exponential expressions that have the same base, then you can add the exponents. We're just reversing that. So if you have addition in your exponent, you can split that up and make it a product of the base to the first term times the base to the second term. So that's what I did here. And again, I wouldn't expect you to think of that on your own. I'm showing you the process. Now, this e to the c, this is a constant. So what we can do is we can actually replace it with something less complicated. So let's replace this because it's just a constant. So we could call it whatever we want. We could call it d. We can't call it c, but we could call it c prime, c sub 1. We could call it, can't use k because k is already used, but we could call it b. We could call it, let's call it a. And the reason I'm calling it a is because that's supposed to show up in our final format. All right, so since this is a constant, we can replace that with anything, any constant we want. I'm going to choose uppercase A. And so here we are at a times e to the kt. We are getting pretty close to this. The way we get to that final format, and this again, you want to mark the time in the video here because you'll need this algebraic technique in the take home for number 3. So in order to remove absolute value, here's how you remove absolute value. You have to put plus or minus the entire other side. Now, in this case, the entire other side is just one term, so I could have just written plus or minus a times e to the kt. And that's how you remove an absolute value. So to remove an absolute value, you can remove the absolute value if you put plus or minus the entire other side. And finally, if we're supposed to get just this format, the reason we can drop the plus or minus here is because we end up with this again is an unknown constant. So we don't know if a is positive or if a is negative. So if a is supposed to be positive in the end, then it will be. If a is supposed to be negative in the end, we don't need the negative out front because this value itself could be negative. So it's a little like kind of like a, you're just kind of dropping the plus or minus because a is an unknown constant. So a technically can be positive itself or negative itself. So it seems a little weird that you can just drop that plus or minus. But in developing this formula, you're allowed to do that. Now, when you're doing the take home, don't just drop the plus or minus. For a lot of examples we do, especially when we're plugging in a number, we have to be careful that if we're plugging in an XY ordered pair, we have to be careful that we pick the correct sign for the front. All right, so just to mention that, but we're developing a formula here. And since a itself could be positive or could be negative, we're okay to drop that plus or minus in this case. So this is our formula. And again, what you can do is when you get up to the AP exam, if you have a problem in this format, you can either memorize what this is. That might be the easiest way to go about it. But you always have the option to develop the formula yourself by solving this differential equation using separation of variables, like we just did here. But it's quite a process. So that's why a lot of students, when they get up to the AP exam, they decide to memorize that formula. Okay, so now that we have developed this formula, we're going to solve two problems involving that formula. Here's our first one. I have a problem that says the rate of change of y is proportional to y. Okay, so that is this exact format. The rate of change of y, the derivative of y with respect to time, that's the rate of change of y. It's proportional, so we have a constant times y. That is the exact format we have here. What we want to do is I have an initial condition and I have another given point, and we want to find the value of y when t equals 3. So what we could do is we could do this entire process again of separation of variables to get to this formula, but let's not. Let's just jump in and use the formula. Okay, so if we were to do separation of variables and solve this for y, we would end up here. We're going to jump right down to here since we just did the whole process anyway. And in order to figure out the value of y when t equals 3, what we need to do is we need to find a and we need to find k. They are constants. This is supposed to be some number for this problem, and this is supposed to be a number for this problem. Only y and t are variables. A and k are called constants or parameters sometimes, and y and t are variables. So in order to find a and find k, we have to use the given information. Now I notice this one has a 0, so let's use that first. So I'm going to plug in 2 for y, and I'm going to plug in 0 for t. And when I do my algebra here, k times 0 is 0, e to the 0 is 1. So what I get is 2 equals a. So I've found the value of a for this problem, and all we need to do now is find k. Now before I continue, I'd like to note, do you notice that the a value here is what you get when t equals 0? That's always going to be the case. So that's another thing where you can always jump in and plug in here. So you can use t equals 0 and y equals 2 to solve. But a is always going to be whatever the y value is when the t equals 0, when the input is 0. So if you'd like to memorize that, feel free. You might even remember that from pre-calc. All right, so I have y equals 2 times e to the kt. What we want to do next is find k. So that's where we use the second point. So I'm going to use t equals 2, y equals 4. I'm going to plug in 4 for y. I'm going to plug in 2 for t. I'm going to divide the 2 to the other side. And then we need to solve. So our pre-calc skills come in here again. So if you had me for pre-calc, we named this the base, the exponent, the other guy, and we rearranged to log base e of the other guy equals the exponent. Depending on the teacher you had, you might have taken the log of both sides instead. Since it's base e, you'll do natural log. And again, you have a composition here where you have natural log of e to the 2k, so those cancel each other out and leave you with 2k. So depending on who you had last year for pre-calc, you have different ways to get there, but this is where you should end up. And if you have questions on that, if you don't remember, feel free to ask. And this is our constant for k. So here we have our model or our equation. So that's where we're at. So we have solved for this. We filled in the constant for a. We filled in the constant for k. So our very last step here is to solve for the value of y when t equals 3. So what we'll do is we'll plug in 3. You'll grab a calculator. You'll put this carefully into your calculator. And what you'll get is about 5.657. Make sure you take a moment and actually find that in your calculator. Oops, that's not legible. That should be a 3 right there. And that's the whole process. So there is quite a bit of algebra review in there, especially with the logs and exponentials. And again, if you have any questions, let me know, and I'd be happy to review that with you. Last example in this video is going to be solving this. This one's like a little different spin on it because in the previous example, we had a bunch of points that were given. We had these 2 points and we had a specific y value that we wanted to find specific t value you want to find y at. For this one, it's a little different because what we have is we have a differential equation. It's in that same format. So it's in that format that we're looking for. Instead of y, we have p instead. That's all. So we have dp dt equals k times p. And we don't have any specific points given, but what we know is the population triples every 10 years, and we want to find the value of k. So the first thing is we can skip the whole separation of variables. Okay, that's that long process we did to develop this formula. We can skip that whole thing and just jump right in and use this formula. Instead of y, we have p. And once we get to here, what we want to do, our goal is to find k. Now this time, I told you this a right here is whatever you get for p when t equals 0. But we're not given any of that information. So there's a different twist on this. And here's how you solve this one. The fact that the population triples every 10 years gives you a comparison you can make. So when t equals 0, I'm just going to say the population is A because we know that's the initial value. Okay, so when t equals 0, the population is A. I'm just going to use that even though it's unknown. And if the population triples every 10 years, when t equals 10, what will the population be? Well, if the initial population is A and it triples every 10 years, then at t equals 10, the population should be 3 times A. And if we go ahead and plug in with those values, even though we don't really have very many numbers, I have too many variables for my liking, we're actually going to be able to solve for k. So what I have here is I'm going to use this information. So instead of p, I'm going to put 3a. I'm going to keep a, keep e, k is unknown, and I'm going to put 10 in for t. And I can actually solve this for k. It seems like it shouldn't be possible, like you don't have enough information, but you do. Because if you divide both sides by a is going to cancel out. This is e to the 10k. And again, to solve this, depending on the teacher you had, you might take the log of both sides, and you would pick natural log because it's base e. Or if you had me as a teacher, you would probably look at this and say, here's your base, your exponent, and your other guy. And the definition of a log allows you to rearrange those. So you're going to have log with base e, you're going to put 3 inside, and 10k will go by itself. So no matter how you learned that skill, you should get to here. And then if you divide both sides by 10, you actually have your value of k. So I didn't put anything like this number 5 on the take home, but I wanted to make sure you saw it at least once because you might see something like that on the AP exam when we get there in May. And if you do throw this in your calculator, it would be good practice to put this in your calculator. You should get about 0.110. And if you go to put that in your calculator, just be careful because when you hit natural log, the calculator opens parentheses. You have to make sure you close them before you divide by 10 because if you don't close those parentheses, you'll be taking the natural log of 3/10. You want the natural log of 3, that entire quantity, divided by 10 to get your correct decimal. All right, thanks for watching.